Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, I'm going to show you how to toggle the pins without using set and clear operations. So in the previous video, we have used set and clear operations, but now in this video, how to toggle the pins without using set and clear operations. So without further delay, let us start today's video. But before starting the video, if you have not subscribed my channel, please subscribe and click on bell icon to get a notification. So without further delay, let us start today's video, how to toggle pins without set and clear in 32-bit microcontroller. Okay, so if you recall our previous programming, so I'll just open my previous okay, so before starting this, let us go back to the registers what we have discussed in the previous theory part. So we have discussed 4 different registers in GPIO. One is FIODIR, that stands for direction, and then one is FIOSET, then one is FIOCLR, and then FIOPIN. So these 3 registers we have used already in the previous programming: FIODIR, FIOSET, and FIOCLR. Okay, so now I'm going to concentrate how to use this FIOPIN and how to toggle without using set operation and without using clear operation. So in today's program, I'll be not using any FIOSET and FIOCLR, but instead of that, I'll be using FIOPIN register, and this FIOPIN register, using this, I'm going to toggle. So let us see how it can be done. So before that, just one point I just wanted to highlight: FIOPIN. FIOPIN is used to know the status of port pin. Okay, so FIOPIN is used to check the status of port pin. At the same time, you can toggle it directly at port pin level. Okay, now let us see how to do that. I'll go back to program here, the last program. So I'll just rename it toggle P 1.16 without set and clear. Without set and clear operation. I'll not use any set operation and clear operations or set and clear register. How to toggle? Let us see now. Main program is same. I have a delay program and I have int main here, and here you can see I'm just configuring all 8 port pins as an output port. So logic lies here. So I'm going to do small change. I'll be using here. I'm going to use register called as FIOPIN, and then I'm going to perform XOR. I'm going to perform XOR operation here is equal to 1 left shift of 16. So what is the meaning of this is toggle P 1.16. Very simple it is. It will toggle. So what do you mean by toggle? Toggle means it is going to clear if it is set. If the pin is set before, it will clear, or if the bit is cleared, it will set. So toggle means it will just invert it. Okay, so that's the meaning here, and then I'll just provide a small delay, approximately 100 I'll give. Okay, so now we will check whether will it work or not, whether will it toggle or not. I'll just close it, save the code once, and just once you toggle, once you save and compile it. Okay, now as you know that I have to go to debug window. So this is my debug window, and just I'll give the run here. So observe what is happening here. This is a port number 1, and 16th position it is toggling, meaning is P 1.16 pin is toggling. Right, so this is what I have given the task. So what is my task? Task says like this: I need to toggle 1.16 without set and clear operations. So this is how I can use with the help of FIOPIN register. FIOPIN stands for fast input output pin state. Directly I'm going to change the pin state by toggling. So this cap is there, no, this cap is nothing but XOR operation. It is going to perform XOR with 1. your bits, whatever you're going to mention the bits, those bits will be XORed with 1. If your bit is 0, it will XOR with 1, output will be 1. And if bit state is 1, it will XOR with once again 1, and it will produce 0. Okay, so like that we can toggle. Now I'll do the small changes. For 2-bit, let us see how it works. I want to toggle 2 bits now. For 2-bit, the mask value is 3. I'll just save it. And then, so now let us check output, how it works. Now it has to toggle 2 bits, P1.16 and 17. P1.16 and 17, both are toggling. Right, so now this is called second bit, 2 bits. Then I'll go for 4 bits. For 4 bits, the mask value is F. Save it and run it. Now it has to toggle 4 bits from 1.16 to 16, 17, 18, and 19. Now you can see 16, 17, 18, and 19. Right? Now let us go to last use case. I will toggle 8 pins together. For 8 pin, I need to give the mask value as FF. So now let us check here. Yes. So 8 pins are toggling. Right? So this is how we are going to toggle the pins without using set and clear operations, using XOR operation, bitwise XOR. This operation, what you are seeing, this is XOR operation with your mask value. Right? So with this, I'll just close today's video. I'll come up with the next video. Keep on watching my channel, know about embedded system, and subscribe my channel. And